So please check if what you have in your notebook corresponds to what I have here. Check to be sure I did not make any mistake. So your R6 is 2 ohms, your R3 is 14 ohms, your R4 is 12 ohms, your R1 is 6 ohms, your R2 is 12 ohms, your R5 is 8 ohms. That's what you have. So if that be the case, sometimes in some textbook you might see this resistor drawn like this. You might see this thing drawn like this. It's still the same thing. So in a situation where it's like this one, it's still the same thing. So let's note that. So please, in our last class, we said that the work done in moving a unit charge through a metallic conductor is directly proportional to the current flowing through it. So he said, yes, to the output. So that gave us that Ohm's law is V equals to IR. Now, please write in your notebook notes. Whenever you are to find the resistance on a circuit, everything here is a circuit. Whenever you have to find the resistance on a circuit, start from the lowest resistance to the highest resistance. Then note here about the principle that will help you solve it. If for this thing in your hall, because you know this thing, your mind will rush and tell you I can solve it. After is this one, do this one. And the worst part is that any answer you solve and give will give you something. But it will be wrong if you are not really following this principle now. So the first thing to note is that to find the resistance on that circuit, the total resistance, start from the smallest one to the highest resistance. That is starting from R1, then moving on. So you are starting from the lowest, or you say the closest, the one that makes it the simplest. So just write the lowest so you don't confuse yourself. Start from the lowest resistance. Why? To find the current and the voltage, start from the highest resistance backwards. I said, to find resistance across the circuit, start from the lowest, you move up. Why? To find current or voltage, you will get current or voltage using the resistance that is given, because resistance that you are giving there makes it easy for you. So that resistance that is there is what you will use to know the currents you don't have, the voltages you don't have. So just write it in this English. As I start to solve, you see what I mean. So to find the current and the voltage, start from the highest resistance, then back to the lowest resistance. Once you know this thing and understand what I'm going to do here, you can solve any circuit problem, provided you look at the circuit, you see that it's having just one voltage. Case closed. But if you look at it and you see that it's having more than one voltage, you will not just use this rule again. You will use the one I will teach you on Saturday, which is Kirchhoff's rule and Thevenin's principle. So now let's start. I will come here. I will say, looking at this, the lowest there is R1 and R2. No be so. So I will say R1 and R2. Are they in series or parallel? These two things, are they not different? Have you forgotten that parallel means something being this way or this way, separate? One series means maybe this way, like something and something here, or maybe something here, something here, something here. We or not in a straight line, that is series. Remember it. Those of you that normally miss class, even later, you come the one you don't like. It will be affecting you small. So this is in parallel. And the combination of these two circuits will give us a new resistance. And that is the combination of these two resistors will give us a new resistance, which we will call the highest resistance is R6. Is it not true? So it will give us a new resistance, which is R7. Please note what we are doing. So I want to use this to refresh our memory on Ohm's law. Then we'll go back to solve those questions from Saturday class. Then if we are done with Saturday class, we'll go back to the remaining questions. Under we will pick this one. So we are getting this. Now let's do this. Now it simply means that using the principle I gave you, please, if this is V equals to IR, now how to know which formula? That is the formula to use for resistance or anything. I'll ask myself, when anything is in parallel, the current and charge are directly proportional, both you know. So when something is in parallel, the currents are not the same. So the current there is what you are looking for. So if I have parallel, from the thing I taught you under capacitance, I told you that if something is in parallel like this, even if it's capacitance, and this is resistor, this is resistor. I told you that if it's in parallel, it simply means that it is broken. The ends are the same. Broken in the sense that what you have here is a parallel line to this one. So even if you come and join something here to connect it to a voltage, they are not the same thing. Like, it's not the same with this. So we say that the current or charge in parallel, they are different. Why the voltage will simply go here, go here. Voltage is the same for anything parallel. So if I know that, I will simply say, okay, voltage will be constant. And I told you that anything that is constant, always call it 1 equals to IR. Let's say I want to find R here. It's the same thing as saying, I know you can do this thing that you normally want to do here, like you say V over I equals to R. But what I'm saying is using this thing and making this, if I make R solid for you see that you now have R equals to 1 over I. Is it not true? So for that reason, it simply means that any resistance you are finding here, the formula to use, without going to be stressing yourself to remember those things we saw going capacitance, is simply going to be done using 1 over the current. So what I mean by that is that if that be the case, let's say I rotate this thing now. Let's say I rotate the I now will be equals to 1 over R. So what I'm simply trying to do there is that the constant, since the constant is on a subject formula side, it makes the relationship between these two to be in a ratio. So if you are to find resistance, you must do 1 over R. If you are to find current there, you must do 1 over current. That's what I mean by this. It's more like an extracted idea you need to keep in mind for when it's parallel for resistor. Assuming it's in capacitance, the formula made it in such a way that parallel should just be straight. Nothing changed. The arrangement is still the same thing. Everything, every understanding of when it's in parallel is still the same. But the only thing that is changing, the only thing that is changing, that is making it different, is because Ohm's law is what is guiding us here. And because Ohm's law is here, by the time you make such a formula constant here, relationship between these two must be 1 over something. So to find resistance must be 1 over when it's in parallel for resistors. While if it's in series, V equals to IR. Anything series, the current or the charge is the same. So here, current is the constant. So you can see if I put 1 here, it will now be 1 equals to V. So V is equals to R. The relationship between these two, if I'm finding V, I will just do V plus 1 plus V1 plus V2 plus. If I'm finding R, R1 plus R2 plus R3, and be going on. So what determines the relationship or formula you are to use to solve for anything is simply check for the one that is constant. Once you find that one constant, make it 1. See if the relationship is going to give you a linear solving, more like a scalar solving, adding up. Or if it now gives you a ratio, if it gives you a ratio, you know this. So that is why when it has to do with resistors in parallel, it's the same way to solve for capacitance in series. While when it's resistors in series, it's the same way to solve for capacitance in parallel. If you don't want to think of that, just remember this thing. This is the 3 keys for that. So with that said, I now know that resistors in parallel, I will just do the same principle I normally use for series. And I told you, instead of doing 1 over, instead of coming to do R equivalent equals to 1 over R1 plus 1 over R2. As a student of this tutorial, you don't need to waste your time doing this. Just say it will simply be R equivalent equals to R1 times R2 all over R1 plus R2. Somebody will want to ask me how, because they are the same thing. If you use the other method or you use this, it's still the same thing you get. So it equals to 6 times 12 all over 6 plus 12. If I punch for me, what do you have? Punch. That is 6 times 12. 72 over 18. I have punch here in 4. Okay. And that 4 is in ohms, Shebi. So please, Shebi, remember why I agreed that we'll be fast. So that's why I won't be beginning to be teaching you all these words. If you watch the video on YouTube, you will see that we've already explained it. Now, what I will do is to now say, okay, since I've gotten R7, instead of calling it equivalent, call it R7. Whenever you're solving for circuits, you're calling it that thing. Remember, I'm telling you, use this. The most important word of reading is anytime you are reading, be sure that you are inventing something you use to remember something. It helps. So instead of R equivalent, you're putting it as R7. So I will redraw this circuit now. Now this circuit becomes however you draw it, whether they're in the same line, it doesn't matter, but just make sure you're putting it where it should be. So remember that so this becomes my R7 now because these two now match together to give me 1. So this is now my R7, which is 4 ohms. So this is now 28 volts. And also notice somewhere in your notebook that I said in a circuit that has resistor, you don't go and be solving unless you are solved to a point where you now grab it well. Else, what you are doing is guesswork. You have to make your habits be in such a way that you always find the whole resistance in that circuit in the very last one before solving for voltage or current. If you are not following this guideline, you will be doing trial and error, making mistake. So now that I have this for R7, 4 ohms, I'll put every other thing back. 8 ohms, that is for R5, then R4, 14 ohms. Oh, bless you. It's you that is in this class. Oh yeah, so please, everything is correct. Now the next one, we are going to be solving this until we have just one resistance. That's what we mean. So let's solve again. Notice something here. Somebody wants to say, okay, why don't you come and do everything around here? Please, remember I said you start from smallest and be going up. Smallest and be going up. Now, if you check this, I have R3. Is it not true? Now, I have R4, but notice that I cannot just solve R4. This R3 and R7, they are in series. You get the point now? So even as you progress in doing this thing, your eye will not be noticing something that when you are finding resistance, it's almost as if you are taking pairs that will easily cancel out to give you something established. So I will now do R3 and R7 is equals to series. And it will give you a new resistance, which is R what? 8. Very important to be noted. All these series we are writing in parallel, you will see the reason why we are writing it. Just make sure you are following this thing we are doing. Now, I'll bring out, since it's in series, the R8 will simply be in series. To find resistance in series, we'll just do what? We'll just add, Shebi. So I'll just do, give me R3 is 14, Shebi, plus R7 is 4, which is going to be equals to what? 18 ohm. Now that I've gotten this, I will now move again to redraw this circuit. This course is a course that if you are doing, you will not be lazy because you need those visual aspects. If you are lazy, what you'll be doing is guesswork. Now I'll have you're drawing how you draw it so that you don't confuse yourself. If you like, you can can put this one here, but me, I'm putting it in a way that I will not confuse myself. So I'm putting my R8 here because these two things will form something. So that means R3 is gone. Hope I'm not confusing you. So I now have R8. I now have okay. Please check. Should everything is in order? Should everything is in order? Check, oh, to be sure I don't miss anything. R6, R4, R5. Then R3 and R7 gave us R8. Now that I've gotten to this point, I will go again. So I will now do R4 now that I'm seeing. This thing now, anytime you see a circuit like this, and you have something inside, everything here is parallel to this thing, and everything here is parallel to this thing. That is to this whatever maybe capacitor or resistor you have here, and we call all those things source. So note that. So R8 is parallel to R4. That's what I'm trying to say. Somebody wants to tell me, okay, but if you check, is it not supposed to be R4 and R8? But my friend, notice I have many things here. I have just, so as you are going, your mind will give you the understanding that what I'm doing is simply the closest to, starting from small, going. So I'll now have R4 and R8 is in parallel, equals to parallel. And that's their parallel relationship will give us R what now? R9. So if I've noted this, since it's in parallel, I'm simply going to just have, or instead of 1 over, I will do that our principle, which is the R9 will now be equals to 12 times, what's in R8? Should be 18. 12 times 18, all over 12 plus 18 equals to, punch for me. When did I say we use this thing? Once we see that the circuit is having just one voltage, Shebi? Is it not what I said? Remember it. So 12 times 18, what do you have? 216, all over, okay. 30, Shebi? Oh yeah, punch for me. 7.2 ohm. So now that I've gotten this 7.2, I will go back here, redraw.
Why do you think I'll go inside and do R?
I should do and do what?
You know when you're solving for R3, this R3, R7. Now this R8, I think it's after R8, you are using R.
Are you here when I mentioned that? Pay attention, oh. It's not when you wake up, you just ask me what you like. Be paying attention to everything. See, everything here, neighbor, is parallel to this, and everything here is parallel to this. The smallest thing here should be R4 now. This R4, if I'm touching this R4, is either I say R4 is parallel to everything here, or R4 is parallel to everything here. Now, this R4 now, it has just one thing, this side, that is parallel to. So it's easier for me to just cancel out the small number, the small, not small number, but just one resistor I have this side. So I just tackle it so that I will now have just one thing. Then I look again. And the minute you do this thing now, it has now dissolved these two, just one resistance. So that one resistance, I can put it here. I will not come back here and put it here. I will not come back here and say, I put it here to be parallel to this. Once I do it, anything that is in between, separating, I remove it. It has combined with this to give it. Because reason is that if I have this going this way, I have this going this way. The minute I pull this thing now and pull this, current will flow more on this. It will continue on this rotation than it wants to go here. So that resistance is on this. So don't do guesswork here. Like you open your eyes to see the pattern I'm using. That pattern, you register it in your head. And that's the pattern you must follow. Because this thing is practical something. And whatever we are showing here is simply based on practical observations. It's not just about imagination, you imagining it. This is real life something. This is electrical engineering we are doing. So if I know that, let's redraw this. I will now have 28V So in summary, it's almost, we are starting small, while still paying attention to how do we pick to cancel out and get something easy. Just the way if you are solving maths, you are trying to see situations that will make you simplify so that you just have something rounded up to give you a final value. That's what we are trying to do here as well. So this now becomes my R9. So you can also note it somewhere in your book when you are solving. Like when you get here, you always, if you see anything that is anything like this break that follows this parallel axis, that you are looking for a way to pull it so that you get to these edges. So not inside. If you remember, even if you remember from when we started the electrostatics, that's our basic knowledge. When we said that charges tend to move towards the surface than it is on the inside. So all those understanding will also be guiding us. So I now have 8 ohms here for R5. Then R9 is 12.2 ohms. Then R6. God bless. So is that our check? Shabi, I did not miss anything. Now notice something, child of God. If you look at this, you see that this thing now. Shall you see? It's more like I have something like this, then I now have the voltage in between. So, and I told you that everything here is in series, because if you check, if you say, let you come and open this thing wide into, open it, this one, then you see that it will give you a straight line. And once you're having straight line, it means series. It means series. So that means that the whole of the resistors I have here is in series. So for that reason, I will not come and do again. I will simply do, once you see one voltage, principle, use it will never fail you. If you're going to be using any other principle, because we still find current and voltage, that's when you've learned it very, very well. You can easily tell the answer without even you solving. That's when you now come and be doing all the other magic will be doing as we progress during the course of this lecture. So I will now have R5 plus is in series, Shebi, and it will give you a new resistance, which is R what? 10 sharp. So now that I have that, since it's series simply means add up, is it not true? So R10 will simply be Shebi? 0.2. Oh yeah, punch for me. R10 will be what? 17.2. Oh. Now that I've gotten this, I don't even want to clean any part of this board because it's very important. Now that I've gotten this, I will redraw these circuits. I will redraw these circuits now so that I now have you can put it anywhere if you want to put it here, but because you are only Shipakaron, you put it in a way that you don't stress yourself. So I'm putting it this way. That is the R10. This thing is a resistor, and resistor offers opposition to the flow of current, which we call resistance. If you missed our class on Saturday, don't think maybe I don't know how to start from the beginning. It's a lie. We've done everything detailed on Saturday. Go and check the video. DC circuits. So go and check. We've detailed all this. So this is 17.2 ohms. This is 28V. So this is for R10. Now that I've gotten here, to now get the current and voltage inside, like across each resistor that you have here. What's that?
I think
Stop disturbing her. Well, if they're disturbing you, change seats. Thank God we have too many positions here. You change seats. Oh yeah. Now that we've gotten this, to find current and voltage, all you need to do for me now is to simply say, come, see, R1 and R2 gave us R7, Shebi. Do you remember that V is equals to IR and R is equals to what? V over I, Shebi. What it means is that as you are progressing through this circuit, through this circuit, and you are doing work, for each resistance that you have a new voltage, and then there will be current drop. So see what I mean by that. What I mean by that is that at the point where you have R1 and R2, which gave you R7, Shebi, please, this thing is in parallel, and I told you that parallel has the voltage to be the same and the current to be different. Is it not true? So since they are in parallel, R1 and R2 will give you voltage 7. This resistance and this resistance giving you resistance 7 simply means that it will have a voltage, a new voltage that is in R7, and that voltage is simply V7, voltage of this resistance. So R1 and R2 coming together, because they are in parallel, their voltage will be the same. Why, if I come here, do you notice how this thing? So a man fi hand a textbook, so be noting it, take it very serious. You will not even see it in your AI. I know what I'm saying. Somebody will say it's a lie. He have academic daddy's invention that works all the time. It never fails. R3 and R7 is equals to R8, Shebi. But notice something. Because they are in series, when something is in series, which one is the same? Is it the current or the voltage? Current. That means that these two will give you current of the resistance 8. If I know that, let's move to the next one. R4 and R8 is in parallel, Shebi. Because they are in parallel, they give you a new resistance which is R9. If it's true, that means their voltage will be the same. That means that their voltage will be equal to the voltage of the 9th resistance. That is the 9th resistor, the voltage there. So if I've noted this, the last one, which is R5, R6, R9, it gave you resistor 10, that is resistance 10, Shebi, and it's in series. That means the current will be the same. It will be the same current which is in the 10th resistor. So I10. So if I've noted this, let me just bring it out to one side. I want to clean this diagram. This particular one, you already have it. So let me just write R1 and R2 is equals to voltage 7. The voltage due to this combination, which is in parallel, can be found in the new resistor. Can be found, the work done to do this, whatever is happening here, provided you have this, the work done inside this resistor is going to be as a result of this combination. So note that. So now, I now have R3 and R7 will give me I8. So note all the reasons by the side. The reason is all these things I'm telling you. So because they are in series, the current will be the same. Because they are in parallel, the voltage will be the same. When we finish, note it. It is always correct. There is no assumption. There is no, sometimes it fails. No. It will always be correct. R4 and R8 equals to V9, voltage 9. R6, R5, R6, R9 equals to I10. So now that you've noted this, You now remember the first principle I gave you. You solve from back, that is the highest, backwards. So I will start from this. See now, the highest resistance here, is it not R9? Shebi? I have R10, remember. Sure, you know I have R10. But R10, I don't need to really use it because R10 is gotten from this thing now. So if I've noted it, I can now clean this. Now to find the current, I'll simply say, let's find the current here. The current here. On each of these now. So always, once you've noted this thing that I've given you, finding that each resistance combined, be it in parallel or series, gives you voltage or a new current. If you've noted it just the way we've noted it, you now go back to using the principle that you start from back, the last value, the last combination going upwards. So I'll now say, to find R5 or R9, anyone there is the same. R5 will be equals to, first of all, we want to find, in this case, we are going to find V5. But let's do it this way, because Ohm's law gave us V equals to IR, and I'm sure you remember. So if that be the case, if this is R5, the voltage will be V5 equals to, the I for this resistance 5 is going to be I10. Because that's the current in, then the R itself is now R5. So if you've noted this, what you now do is to ask yourself, do you know the current in R10? You don't know, but it's easy to know. Because if you check it, this is the final voltage, the final circuit, is it not true? So I can easily come to this final circuit and simply do, I can simply come here and find the final current. I simply do V equals to IR, and this is V10. The final voltage is this. The current 10, resistance 10. So it's going to be, to find the current will simply be I10 equals to V10, which is 28, all over the R 17.2. So I10 will be equals to a punch on it. Punch. 1.62, which is approximately 1.63, Chevy. Ampere. If you can learn this thing, that is, if the voltage 1 voltage, no matter how big the circuit is, you use all these principles, you always be correct. Now, if I've noted that, I'll simply go and say that means V5 will simply be equal to, do you know why? Shall we know it's because it's in series now? So it will be the same. I'll just do 1.63 times R5 is what? What's this resistance 5? 8, show me. Equals to, I punch it for me. What do you have? Punch. If you go and say you want 17.04, which is approximately 17, but let's use it volts. Now, for V6, 1.63. So it's the same thing. You come and do I10, then R6, which is going to be the same thing as saying 1.63 times R6 is what? 2. I have punch for me. 3.26. Shabi? Yes. Volts. I want to clean. So for R9 will be V9 equals to I10 R9, and V9 will now be equals to 1.63 times R9 7.2. I have punch for me. What do you have? Punch. How many of you are with calculator? 11.7? 11.7? Please, I want you to know that all these things I'm teaching you, before we finish this class, I'll still teach you how to use calculator and solve it. The trick. You can use calculator to do everything we are doing here using matrix. So please, if you have MS calculator and ES plus, you carry it and come to class on Saturday. Please, and remind me, 11.736, which is equals to 11.74. You wouldn't want to go inside the exam hall and be solving this thing. It's stressful. Once you have circuits big like this, it's either the examiner know that everybody is supposed to fail it, or people that will get it should suffer and be going through long process. So that is why if you are doing the calculator trick, simply you get the answer without stressing. So V. Now that we've gotten V9, now see what it helps us do. Do you know what all these things helps us do? See that I have V9 now. So if I come here, I can say R4 and R8 is simply equals to 11.74. That is why I said start from the last one, that is the final resistance, and then be going up. So when you're doing it, it helps you once you're able to outline this thing. Now see, I've gotten somewhere V7. Have I gotten V7? Okay, I've not gotten it, not to panic. Okay, then what else? Okay, still VV I've gotten, no problem. There is no shaking. So let's go. When I say for R4, I have that R4 is going to be the same thing as saying, using our principle, using the same principle, V4. Okay, no, we don't have to use V4 now because R4 is equals to V9. So when I say V9 equals to I4 and R4. Shall you see it now? So that when I do to get the I here now, this I4 we are looking for in this case. So anyone that we have this equals to, you see that it helps us know what we are arranging. So we now do I4 to find it will now be equals to V9 over R4, which is equals to 11.74 over R4 is what? And the mistake you make is if you start forcing it, don't force it. Just follow the principle. You always get the answer. What's the R4? 12. Punch for me. 11.74 over 12. Punch. 0.97. That is 98. Okay, that is in ampere. Now to get our, you go back. V, the same V9 again will be equals to I8 R8. So we now do I8, the current there will be equals to V9 over R8. Make sure we are not making any mistake. So V9 is 11.74. R8, what's the value? Hope you are giving me the right value of R, the resistance. 18. I punch it for me. What do you have? 0.65 ampere. Then we are done with that one. So it helps us now that we can now see that we now have I8 equals to 0.65. Never force it. If you force it, you make mistake. Never force it. Once you are following the principle, it will just be leading you. Then we move to R3 and R7. So using the same principle of V3 now is equals to I8. Sure, you know why I'm using I8? Sure, you know why I'm using I8? Because everything on that R3 is having a current that is in that resistor 8. So then my R3. So that this will then be equals to, I don't know the V here. So anyone that you see that thing to be equals to, that means that you are going to find the V. And if you see V, you're going to find the I. So it's not hard, but you just need to go and internalize it. So V3 will now be equals to I8 is 0.65. Then R3 times R3 for me. What's R3? Is it 14? Yes. Punch. V3 now will be equals to punch. 9.1 volts. Please be sure, be checking this the answer so that they don't confuse us. So on Saturday, if we do maths, genetics, we make time to do just the two remaining principles, Kirchhoff and Thevenin, so that upper Saturday will not enter magnetism. So that means we are saying goodbye to electricity on Saturday. Then within the coming week, that is next week, we use it to solve questions on electricity, but upper week Saturday will be on magnetism. So then we have for R7, so it will be V7 equals to I8, then R7. Hope I'm not confusing anybody. Nkunu boheraya, let the man be solving. Hope I'm not confusing anybody. When you then go to your hostel, I was just looking at the man. I wasn't even following him. Please, be getting the reason why we are doing all these things. It helps us, because if we allow you, start going back to the circuit, each one, be checking how you go about the current, what is here, what is not here. You will always make mistake each time, to be plenty. But once you follow this method, simply knowing that even if you are coming to see that this thing is equal to I8, you will say, okay, since this is I8, but you're talking about R7. R7 has current that is in resistor 8. It has nothing to do with the voltage. The voltage of R7 is still voltage in R7, but the current is in the one in R8. That's why we have this. So don't confuse it. So that is why I'm doing it. I just put what is the same there. The rest maintains what it's supposed to have. So I'm going to be having V7 to be equals to 0.65. Oh yeah, R7, give me R7. Punch. 4. R7 is 4. So V7 is going to be 0.65 times 4. What's the answer? 2.6 volts. Shall we? Okay. I noticed that during the week, are you following us? Okay. I noticed that during the week, both people that have not paid us for tutorials will come for our class. Then people that have paid will start home. If you've not paid us for tutorials and you are not ready to pay, stay in your house. It's not a problem. We are not angry. First semester, some people will come and say, if you are telling them to leave the class, they'll say it's because I have not paid for tutorial. Who cares? Stay in your house. Nobody is forcing you. If you can read on your own, no problem. But don't come and stay here and be disturbing us. Be gaining free knowledge. Stay in your house. Your reading and what we are teaching here will go hand in hand for greater results if you are somebody that is attentive. So if you think your reading alone can do it for you, stay in your house. Don't come and be staying in my class, be checking for who is good person and who is bad person. Stay in your house. Oh yeah, so now see, I've gotten V7. That means it's not easy for me to come and simply put equals to 2.6 volts here. So now to find R1, I'll simply now do V7 equals to I that is in resistor 1 and then R1. So that you now see that this is not going to be, if you are getting it, it now has to be I1 equals to V7 over R1. Are you following this? You know that I think the problem is you need to work more on indices and logarithm. You need to do it over, master it. It's not like you need it to. I've noticed that some of the things that you are having issues with is in that line. It's not like it's here, but it will help you be able to see certain things and easily articulate it. So I now have I1 equals to 2.6 all over. And what's the resistance on resistor 1? 6. I punch for me, what do you have? 0.433, okay, ampere, sharp. Now, for R2, I'll have V7 equals to I that is in resistor 2 and resistance in resistor 2. So if I do this, it will not be that I'm not going to be having I2 equals to V7 over R2, which is going to be the same thing as saying I2 equals to 2.6 all over here. Resistance in the second resistor is what? 12. Punch for me. 0. That is approximately 0.2. Sure, you know. And very simple like that. So this is how you find the voltage and how you find the current without stressing yourself. Please stick to it. Try to memorize it. That is how you go about that. Always. So with that said, please check our Saturday class. Check our Saturday class.